Now in this next subtopic here, we are still continuing with solubility equilibrium. And we are specifically looking at solubility of sparingly soluble salts. Sparingly soluble electrolytes. We have seen a KSP expression, we have seen equations, we have seen experiments to determine KSP using both direct titration and also conductivity measurements. What do I want to look at now? I want us to look at factors affecting solubility of sparingly soluble salts. Factors affecting solubility of sparingly soluble electrolytes. These factors are basically three factors. Which factors are they? They are basically three factors. The first factor is common ion effect. That's the first factor that affects solubility of sparingly soluble electrolytes. The next factor, apart from common ion effect, is complex ion formation. Second factor is complex ion formation. The third factor is none other than addition of a soluble compound to the saturated solution. Addition of a soluble compound containing no similar ion as those of the sparingly soluble electrolyte. Those are the three factors that affect solubility of sparingly soluble electrolytes. However, in this lesson, I'm going to look at only the first one. We shall look at the other two in our next lessons. So the first factor is common ion effect. First factor is common ion effect. What is common ion effect? The way you hear it, common ion effect. What is common ion effect by definition? So common ion effect is the precipitation. This is the precipitation of a sparingly soluble electrolyte or compound. I told you the word electrolyte or compound is better than salt, because not all sparingly soluble compounds are salts. Precipitation of a sparingly soluble electrolyte from its saturated solution, the solution must be saturated from which that electrolyte is being precipitated, from its saturated solution. How is it precipitated? By addition of a solution of a more soluble electrolyte. Addition of a solution of a more soluble electrolyte containing one of the ions of the, so long definition, but clearly understandable, the sparingly soluble electrolyte. Precipitation of a sparingly soluble electrolyte from its saturated solution by addition of a solution which is more soluble and containing one of the ions of that sparingly soluble electrolyte. Can we look at an example? Muhammad, give me any sparingly soluble electrolyte you know.
Calcium sulfate.
Perfect. Calcium sulfate is sparingly soluble. Now, when I dissolve an excess of calcium sulfate in a given volume of water and filter, I obtain a saturated solution of calcium sulfate. When to that saturated solution of calcium sulfate, I add another soluble compound. Tell me any soluble compound that contains any one of the ions that are here, but is very soluble. Which one can we think of?
Calcium nitrate.
Very good. You can think of calcium nitrate. Calcium nitrate is a very soluble compound, and it contains a common ion that is the calcium ion, which is also here. So the common ion in the calcium sulfate you've added is the calcium ion. What happens when you add calcium nitrate, a soluble compound, to a saturated solution of calcium sulfate, sparingly soluble? Look at the chemistry here. Calcium sulfate is sparingly soluble in a solution to form calcium ions and sulfate ions. When you add a soluble compound, a soluble electrolyte like calcium nitrate, this one being very soluble, it will completely ionize to form calcium ions and sulfate ions. Form calcium ions and sulfate ions. When you add it there, it is introducing calcium ions, which are common to the calcium ions in the formed by the sparingly soluble calcium sulfate. Are we together?
Yes, teacher.
Yes.
So these excess calcium ions that are introduced here will react with sulfate ions to precipitate calcium sulfate. So what happens? When you add calcium ions, the excess calcium nitrate, the excess calcium ions added will react with the sulfate ions to precipitate the sparingly soluble calcium sulfate, shifting this equilibrium from right to left, reducing the concentration of sulfate ions in solution, but increasing the amount of the sparingly soluble calcium sulfate. So from this, we are aware that addition of a common ion to a saturated solution of a sparingly soluble electrolyte decreases solubility. Why does it decrease solubility? because of what I've explained here. So what shall we say here? They can ask you to explain the changes that take place. Actually, this has been bringing me to this definition here. The precipitation of a sparingly soluble electrolyte from its saturated solution by addition of a solution of a more soluble electrolyte containing one of the ions of the sparingly soluble electrolyte. The other way I can do that is by addition of maybe sodium sulfate. Sodium sulfate is also very soluble, introducing sodium ions and sulfate ions. This one completely ionizes. So the excess sulfate ions here will now react with calcium ions, form sparingly soluble calcium sulfate. So common ion effect in general, common ion effect decreases solubility of a sparingly soluble electrolyte. Decreases solubility of a sparingly soluble electrolyte. So here I'm going to look at one question, and that will mark the end of common ion effect. The question says, explain what would happen to the solubility of calcium phosphate. What would happen to the solubility of calcium phosphate if in water, solubility of calcium phosphate in water, if each of the following is separately added. Separately added. Roman 1, sodium phosphate. Roman 2, calcium nitrate. Calcium nitrate. We are explaining. Sometimes they say state, and most students confuse those two terms. When they say state, you don't have to explain yourself. Just tell us what happens to the solubility. And here you'll simply say solubility decreases, full stop. When they say explain, then go ahead to explain. When they say state and explain, you state and also explain. Now let me begin with addition of sodium phosphate. Look at the two compounds given. This is calcium phosphate. This is sodium phosphate. So this is testing a common ion effect. There is a phosphate here, there is a phosphate here. This is calcium nitrate, and this is calcium phosphate. The common ion being introduced is the calcium ion. So you must base on those two to give your explanation. Let me look at Roman 1 first. When you look at Roman 1 first, we are adding calcium, we are adding sodium phosphate added to calcium phosphate, which is sparingly soluble in water. Write this equation for calcium phosphate. The phosphate radical has valence 3, calcium has valence 2. It's a solid plus aqueous gives me calcium ions, which are 3 of them, and phosphate ions, tri-negatively charged, which are 2 of them. What are you introducing? You're introducing sodium phosphate. That's the formula of sodium phosphate. It's a very soluble compound. It gives me 3 sodium ions and phosphate ions. What is the common ion here? it is the phosphate ion. After writing those two equations, we can now explain what will be our explanation. This is how our explanation goes. Remember, the question says, explain what would happen to the solubility. Begin by telling us that common ion effect decreases solubility. So we'll say solubility of calcium phosphate decreases in water, decreases. Why? Why does it decrease? This is because sodium phosphate remember, in your explanation, you must not talk about the word common ion effect. It must not appear in your explanation because you are explaining what it means. This is because sodium phosphate contains phosphate ions. Contains phosphate ions that are common. I'm not mentioning the word common ion effect anywhere. That are common to phosphate ions. That are common to phosphate ions in calcium phosphate. What happens? The excess phosphate ions, let me use symbols here to save space. The excess phosphate ion is added from where? From sodium phosphate, combined with calcium ions. These ions here, combined with calcium ions in the solution to precipitate calcium phosphate. I'm using formula, but in exams, please use words, not formulae, in your exams. Precipitate calcium phosphate. Why does that occur? In order, that is done in order to restore in equilibrium. This equilibrium here, in order to restore equilibrium. In order to restore equilibrium. In order to restore equilibrium, maintaining the value of the equilibrium constant. Maintaining the value of the equilibrium constant. Briefly, that's your explanation. Briefly, that's the explanation that is required here. So how do we award the marks here? How shall we award you in case you do something like that? You don't need to write a lot of words. Just have to write. Don't have to write a lot of words. Just have to write a few words, but straight to the point. So how shall we award you here? Shall give you half a mark by telling us what happens to the solubility. Talking of phosphate ions that are common, phosphate ions in calcium phosphate, we shall give you a mark that the excess phosphate ions, we will introduce what happens to them. They combine with calcium ions to precipitate calcium phosphate. Why does that happen? To restore equilibrium such that the value of the equilibrium constant is maintained. And that will give you 3 marks. Are we together?
Yes, teacher.
Now, I'm going to simply play around with this answer here. Remember our next question was saying, what happens when you add calcium nitrate? What happens when you add calcium nitrate? Let's see what happens when you add calcium nitrate. When you add calcium nitrate, what's going to happen? Just going to modify this thing and you see that the explanation is the same. There's nothing different here. There is nothing different here. Not mentioning the word common effect anywhere. So let's see. We are now adding calcium nitrate, which is a soluble compound. According to our definition, it brings out that very well. We're adding it to calcium phosphate. So calcium nitrate, being a strong electrolyte, it will completely ionize in the solution to form calcium ions and phosphate ions. And nitrate ions. These are two nitrate ions. There's a two here. Two here. So the solubility of calcium phosphate will still decrease. Why? This is because calcium nitrate. Contains nitrate, not nitrate this time, contains common ion here is now calcium. These calcium ions that are common to calcium ions in calcium phosphate. So the excess calcium ion is added, combined with now, excess calcium ion is added now, combined with, what will they combine with? Combined with phosphate ions. These ones here. To precipitate calcium phosphate, why does that happen? To restore the equilibrium, maintaining the value of the equilibrium constant. Hoping that everything is clear, I want you to make research and read about applications of common ion effect. Make research and read about applications of common ion effect. Common ion effect is applied industrially. Remember, in the preparation of soap, there is a procedure called salting out soap, whereby you add brine. You add brine to soap. The common ion there is usually the sodium ion. It plays a role in salting out soap. Common ion effect is also applicable in purification of common salt, sodium chloride. Look at that in detail, make research and read about it. Our next factor will be the common ion effect. We shall see how it affects solubility of sparingly soluble salt. And we shall see that for it, it increases solubility. Whereas common ion effect decreases solubility of sparingly soluble salts, complex ion formation increases the solubility of sparingly soluble salts. Thank you for viewing this lesson. Subscribe to our YouTube channel for more of such videos. Don't watch and forget to subscribe. We meet next time. Thank you. Stay safe. COVID-19 kills.